Good day. This is the presentation for WQD 7005 Data Mining Project, Part 2, which is storing data into Hive. I'm NgJiunnJye. For today's agenda, what I'm going to cover is the prerequisite for Hive, which is Java, Hadoop HDFS, and content store, how to set up Hive, configure Hive through the Hive site.xml, and how do we start Hive, which it comes in two mode, which is the standalone mode Hive, or we can start in a Hive server mode plus beeline. And we look into how we can store different kind of data into Hive. For this, we explore the CSV data and the JSON data. And lastly, we are going to explore the data that we have stored into Hive. That is done through select statement, and we'll also be exploring it through HDFS to see how the data are being stored. First, let's look at the prerequisite for Hive. The first prerequisite is Java. So we need to make sure that the environment that we have has a Java installed. For this project, I'm going to set up my Hive inside my Ubuntu VM. And from Ubuntu, how do we check whether Java is installed or not? Typically, that is being done by running this command, Java, and its version. So if the Java is available, then we are going to get this version information, which is the one that I have is the OpenJDK version 1.8. And what we need to do next is we need to make sure that the Java home is being set up as part of the profile, so that when the program tries to look for Java home, it is able to locate the Java. Let's see. So we can see the Java home by running echo Java home. And in my environment, Java home is being set up into this path. Typically, the Java home is not being set up when we install Java home, when we install Java. And how we set up the Java home is by editing the .profile file in our environment. In this case, my Java home is being set up this way. Alright, I know my Java is being installed into this userlib JVM Java 8 OpenJDK. So this is where I put the Java home. Alright, next we look into the prereq, which is the Hadoop HDFS. So first we need to install the Hadoop HDFS, and we need to make sure that the Hadoop service is up and running. So how do we check that the Hadoop HDFS services are up and running? So the easiest way to check is to go into the server node that I am having and try to run this command, ps-ef grep name node. In this case, it doesn't detect any name node. We can also check for data node, and data node is not running as well in this environment. So Hadoop HDFS is made up of two main components, which is the name node and the data node. So assume that the name node is something similar to what our OS, how we can do a list files and how we can manage where the files is. That is being done by the name node, and the data node is physically where the file is being stored. Think of it as our physical hard disk. That is the one that store the data node. And data node can be distributed. We can have one or more data nodes, and that will help us in distribution and replication of the files. To start the HDFS process, what we can do is first go into our Hadoop installation path. Alright, and then go into sbin, and from here typically it comes with this file called starthdfs.sh. You can run it by executing this. This is assuming that all the HDFS prerequisite and the configuration has been set up accordingly. So when we run the start HDFS, it will start the name node and the data nodes. Alright, so now the name nodes, data nodes, and the secondary name nodes has been started. Now we can run this ps command again, and we can see that there's a name node running. We can see too because the second one is a secondary name node. And let's check for data node, and yes, data node is up. So once the name node and data node is up, we should be able to check the status of HDFS through the HDFS UI. Alright, let's take a look at the HDFS UI. So the HDFS UI, by default, it is being set up on this port 9870. And when we go inside here, this is the default view, which is the DFS health view. We can see the overview of this HDFS, the summary. What we need to look up for is this one, safe mode is whether on or off. So when there's some problem, if the safe mode is being on, then we will not be able to write into the HDFS. So this also comes with some utilities for us to check the health of the data nodes. So from here I can see that for this setup, this cluster, I have a one node data node, and the one node data node, the status of it is green, it is in service. And it still have, this is the capacity, it still have lots of this space available. And this also comes with some utilities such as this, which we can use to browse the file system on HDFS. I will go into detail when we explore the data later on. Alright, next we look into how to install Hive. Typically when we install Hive, it comes in the .gzip folder format, and what we need to do is to FTP the files into the environment that we want. And here's a file that we downloaded, and what's next is just to untar this file. This can be done by running this command, and this will untar the Apache Hive into this folder. So in my environment, I have already re-extracted thing, so the Hive is now being set up in this folder. So once that is done, there's two things that we need to do, three things actually. So first, we need to set up in our environment variable where is the Hive home, and then we need to include the Hive into the path. So how we do that is by again going back into our environment and look into this file profile, and depending where we set up our Hive, we will set up the Hive home to that path, and we need to add this to the bin of the Hive home into the path as well, so that we can run Hive from any place within our file system. Next, what we need to do is we need to set up where is Hadoop home. We need to tell Hive where is our Hadoop being installed. So this is being set up in this file, hiveconfig.sh, inside bin folder. And we do that by updating this line, export Hadoop home equals to the environment that we have set installed our Hadoop. Then what we need to do is we need to run a HDFS command to make a folder inside our HDFS, which is the user Hive warehouse. So this is being done by executing this command, hadoop dfs-mkdir-p/user/hive/warehouse. So once this is completed, we will be able to see this folder through our HDFS UI. Here is our HDFS UI, and you can see that the user Hive warehouse that we have just created just now will be available inside HDFS after running the HDFS command. Next, what we need to do is we need to create a content store for the Hive. So for Hive, it supports a few content store according to the template. Okay, the content store supported is DB, Oracle, MySQL, MSSQL, and Postgres. So for this project, I'm going to use Postgres as my content store. This content store is being used to store any metadata that is required by Hive. To do that, what we need to do is, first we need to go into my Postgres environment and need to create a Hive user with a password and create a new database. In this case, I'm going to call this as metastore. And once I've created this, what I need to do next is to go to Hive config folder, create the Hive site XML, and create all the necessary properties to let Hive know how to connect to this Postgres database. I will show this on the file system. So now go to conf folder and create a file called hive.site. And in this Hive site, this is where we give the connection URL to let it know how to connect to the database. We give this is the JDBC URL. Instead that is a JDBC. Database use is PostgreSQL, and this is the path how to find the PostgreSQL instance. And the second configuration is a driver. This is to tell which driver to use to connect to this database. And we need to provide what is the username for the connection and what is the password for this connection. So once this is being set up, next what we need to do is to create the content store. So creation of this content store is quite easy. So Hive already prepared a tool called schema tool, and this can be used to create the content store. Now let's look. Okay, let's go back to our bin folder. There is a schema tool which is available. So the command to run is schema tool -db type. We need to let it know which database type we are using. In this case, it's Postgres, and -init schema. So once this is executed, it will connect to the Postgres environment and create all the database table and views which are required for this content store. Once the content store has been created, we can start the Hive process. There is two ways how we can start Hive. One is by running Hive, the other one is by running Hive server and beeline. The difference is Hive is a standalone environment, a standalone Hive execution where we will run Hive and we can have only one connection connected to Hive, and while Hive server allow multiple clients to be connected to Hive. So for this project, most of the time I'll be using Hive, but I'll be doing a simple demonstration how we can start Hive server and beeline at the end of the presentation. Now let's look at running Hive. Back to our environment again. You can see that inside our Apache Hive bin folder, there is a Hive command. This is the one that we need to run to start up the Hive. So if everything is configured correctly, we should be able to get a Hive prompt once we start the Hive process. Great, we've got our Hive prompt and there's no errors. Let's see, what do we have here? We can run the command show databases, which will show us what are the databases that we have created. So in this case, I have created a data mining database, and there will be a default database being created by Hive when Hive is being installed. Next, we look into how we can store data into Hive. There's three-step process and how to store data into Hive. First step, we need to know what is our data. So for example, in this project, I have some of my data coming in as CSV and some of my data which I've created using JSON. Next, we need to create a table to store the data. And third, we need to load the data into Hive. Now, let's look at our data again. Okay, if you remember our data, we have the data coming in, those that is downloaded, we have in CSV format, and we have the data that we have scrapped from the aqicn.org.com website. So those data, live data that come from the AQI website, I have pre-created them in a JSON format. Let's take a look. So the data is in JSON format here, and we can take a look at those CSV file that we've downloaded. Alright, so these are the CSV file. CSV stands for comma separated file. See, the data has come in with comma separating the fields. These are the CSV files. Now let's look into how we can store the CSV files into the database. So first, we need to create a table to store this information. So in this case, I call this table as Malaysia AQI history because it contains data from the years before. It is not coming from live data. And I need to create the columns for each of the fields which are available in the CSV file. Let's take a look again. So we have Tariq, which means the dates, Waktu, which means the time, Negeri, which means the state, and Kawasan, which means the district, and the API value. So in this case here, I created the field name as OBS, stands for observation date, and OBS time, which stands for observation time. The reason I don't use the exact date and time is because date and time is a reserved word, and we cannot use this to create a column name. And for the other fields, it will be quite self-explaining: the state, the district, and the KP and the API. Next, we need to tell what is the data format. In this case, it is a CSV. CSV, it is a row format delimited, which means the fields are delimited, and the fields are delimited by a comma. And we want to store this data as text file. And the other thing to note at is this file has a header entry. We do not want to insert the header entry into our database table. And to do that, what we can do is we can set up this table properties to say skip header line count equal to 1. So what this will do is it will skip the first line when it loads the data. Now what we need to do is to take this command and goes into our hive prompt, and we can run this command to create the table. Alright, in this case, this creation failed because I have already pre-created the table. But if the table is not there, so this execution will be completed correctly with the new table being created. Now, once we have created the table, what we can do next is to load the data into the table. Alright, to load the data, this is the command. We tell it to load data from local in path, which is the path where we have stored our data. And then we will tell it to write it into which database table that we want to write into. Excuse me, this is the wrong table. We should be we want to store the AQI history, and the AQI history file is this file, which contain it's not this one. So this is the command. So this file contains the reading, the API reading for the year 2005 up to 2013, and this file is located in this path. So what we can do is run this command, load data local in path, the location of the file, and override into table. This is the table that we have created to store this information. So we should be able to run this. Alright, so now the data has been generated. We can select from this table. Alright, so we can have a look at the first 10 fields from this table that we have just inserted. Alright, so we've seen how to insert the CSV file into the hive table. Now let's look into a JSON format. let's look in some of our data that we have. So this is a sample JSON file that we have created, that we have scraped from the website aqicn.org. So it contains the city, time, AQI, temperature, pressure, humidity, and wind. So to generate the table to store this, first we need to create a table to store this data. I call this the Malaysia Live AQI table. So the fields that we have is the city, ops time. The reason why we need to use ops time instead of the time is because the time is a reserved word in Hive. We are not able to use the time as the column. And the rest of the field, AQI, temperature, pressure, humidity, and wind. So since this field is a bit different, we need to clean our data. What we need to do next is we need to go to our data and remove the time column and change it to call it as ops time. So this way we will be able to insert this file into this table. And the next to look at is the row format is for this type of file is called SERDER. SERDER stands for serialization and deserialization. And the library that we're going to use is this OpenXData JSON SERDER library. Alright, so to do this, what we need to do is first we need to download this library, and let's take a look. Go into the folder. We need to add these files into the environment. So once this file has been created, then you will be able to do the JSON serialization. Alright, so now let's look at our file again. So this is our file, and what we need to do is we need to modify the file. By changing this field time into ops time. So that can be done through a set command. This will replace the field time and change that to ops_time. Alright, so once we change that, all of you will become ops time, and we can use this command to load the data into the table. So before that, we need to first create a table. The table creation is done by the scripts. Alright, and this failed because I already have this table pre-created earlier. And next, we need to run this command to store the data in the JSON data into this table. The command for this is similar to the CSV file. It's load data, go in path, which is, and then followed by the path of the data, override into the table Malaysia Live AQI. So now once it's loaded, we can take a peek at this data. Oops. Alright, so what happened is some of the file has the field none. So this is a JSON error. So we need to fix this none and replace it with field which doesn't have a none field. Let's quickly try to fix this. So what we can do is we can ignore the columns that has the field none. So we can do that by skip all the rows that has the field none and write it into or air quality followed by the clean.data. Alright, so now we shouldn't have any none. And I forgot to say that. Let's place that again. This is to change the field time to ops time. And now let's drop this table and recreate. Okay, and let's create this table again. Now the table is created. Alright, so this table is empty. Now we can load the data again. Now we should use the clean data. Alright, and let's see if this works. Cool, it's working now. So this is part of the data scientist work, which is to clean the data that has been passed or scrapped. Alright, now that we've seen how to insert the data into the table, we can see how we can query the data from the table. As I just demonstrated here, I can run a select statement to query the data out from this table. So this supports most of the SQL statement. And the other thing to take note is, so what happened when this data is being stored into Hive? So behind the scene, Hive requires HDFS to work. And if you look at here, so the files that we have created, let's look at this one. What did happen in the background is this file is being stored into the Hadoop HDFS. This is the exact file that we just inserted just now. And Hive, when we insert this file, Hive will create the metadata information to understand how to read this file and how to pass the columns for this file. Those are being stored into the content store. That is the use of the content store. Alright, now in the beginning of my session, I mentioned that there's a Hive server, and I'll demonstrate how to use that as well. So it is basically quite simple. If you go into Hive, you see that there is a Hive server available. So to start this Hive server, we just need to run Hive server 2. Alright, let's wait for a while. Alright, now Hive has been started. This is the Hive server. Let's take a look. Alright, the Hive server has been started. And what happened is Hive server will be started. Typically, you listen to a port 10,000. Let's see. This is the PID. It's a PID, and we try to see which port has been used by this. Apparently, okay, now it is up. So this 10,000 port is up and listening. So what we can do now is we can run the beeline program. Okay, so the beeline program is available inside the bin folder of the Apache Hive. So what we can do is run beeline program. We need to tell it which database to connect to. So what can happen is this can be running from a totally different node. It doesn't have to be running on the same node. Okay, so we need to provide the JDBC connection, Hive2, and this is the host. In my case, I'm running on a local host, and followed by the port, which is by default 10,000. Okay, again, so what will be interesting is if you run this from a different environment that has the beeline program, it can connect from external. Okay, so we're just trying to connect, and here we have the connection. Let's see. You should be able to see the database that we have created just now, which is data mining. Okay. Data mining is available. Let's see the tables, and we will have the data. Let's try to select from here. Okay, so this is the same data that we've just inserted. Alright, so now we can see that this is the top, this is the 10 of the rows that has been inserted. You can see the data are available. Alright, so that's the end of my presentation. Thank you.